Hey makers, welcome once again to Uptricity Embedded Sphere, where we explore embedded systems and DIY electronics using real-world components available right here in Nigeria. In the last video, we made a multi-sensor environmental monitor, but this time we will be adding a Wi-Fi module and will be uploading the readings to an IoT platform called ThingSpeak. It even includes a buzzer alert when the gas level gets dangerous, making it ideal for home safety, labs, and green IoT projects. All components used in this project are available on hub360.com.ng, Nigeria's reliable source for embedded hardware. Let's dive in. This system monitors multiple environmental parameters using sensors and sends the data to the internet. Here is how it works. A BMP180 sensor gives us temperature, altitude, and pressure. An MQ2 gas sensor detects smoke or gas levels. An I2C LCD shows live sensor readings. A buzzer goes on when the gas concentration exceeds a defined threshold. Data is transmitted over Wi-Fi using ESP01 and posted on ThingSpeak in real time. Components used: one Arduino Uno, one MQ2 gas sensor, one BMP180 temperature and altitude sensor, one I2C LCD display, one ESP01 Wi-Fi module, one active buzzer, three 220 ohms resistor used as a voltage divider, jumper wires, and breadboard. All available at hub360.com.ng, tested, trusted, and delivered fast. Connections. Let's wire it up. Connect MQ2 gas sensor to Arduino. VCC of the MQ2 gas sensor to 5 volts of the Arduino. Connect the ground of the MQ2 gas sensor to the ground of the Arduino. Connect the MQ2 gas sensor A0 to the pin A0 on the Arduino. Now connect the BMP180 sensor to Arduino. First, connect the VCC of the BMP180 to 3.3 volts on the Arduino. Connect the ground of the BMP180 sensor to the ground of the Arduino. Connect the pin SDA to the A4 pin on the Arduino. Connect the pin SCL of the BMP180 sensor to the pin A5 on the Arduino. Now connect the I2C LCD display to the Arduino. First, we connect the VCC of the I2C LCD display to the 5 volts of the Arduino. Now we connect the ground of the I2C display to the ground of the Arduino. Next, we connect the SDA of the I2C LCD display to the pin A4 of the Arduino. Connect the I2C LCD SCL pin to the A5 pin on the Arduino. Note: shared I2C with the BMP180. Note: the LCD is shared with the I2C of the BMP180. Now connect the ESP01 Wi-Fi module via software serial. Connect the TX of the Wi-Fi module to D6. Connect the RX of the Wi-Fi module to D7 using a voltage divider on TX to avoid damage to ESP01. 220 ohms between Arduino TX and ESP01 RX. Connect 440 ohms, that is 220 ohms in series between ESP01 RX and ground. This drops the 5-volt signal to a safe 3.3 volts, protecting your ESP01. No level shifter, no problem, just 3 resistors and you're good to go. Connect the VCC and channel pin on the ESP01 to the 3.3 volts of the Arduino. Connect the ground of the ESP01 to the ground of the Arduino. Connect the ground of the ESP01 to the ground of the Arduino. Now move to the buzzer. Connect the positive pin of the buzzer to pin D3 on the Arduino. Connect the negative pin of the buzzer to the ground pin of the Arduino. Important note: ESP01 should only be powered with 3.3 volts. Never power it directly from 5 volts. Now let's go through the code and explain how it works. Library inclusion. We include libraries for software serial to communicate with ESP01, BMP180 for temperature, pressure and altitude, liquid crystal I2C to drive the LCD. Pin definitions and global declarations. Setup pins for the gas sensor, buzzer and the RX-TX pins for ESP01 communication. Create sensor and communication objects. Wi-Fi credentials, API key and gas safety and threshold. Custom data structure. This stores all the sensor readings neatly in one structure. Setup function. Initialize pin, serial counts and LCD screen. Try initializing the BMP180. If it fails, halt the system, then connect to Wi-Fi. Loop function. Read temperature, pressure, gas level and altitude. Display all the readings on the LCD screen. This sends the data to the ThingSpeak cloud every cycle. Send data to ThingSpeak. This prepares a JSON payload containing all sensor readings. This creates a valid HTTP post request with headers. This open TCP connection, send request and close connection. Wi-Fi and AT command helpers. This basic ESP01 setup command. Reusable function to send AT commands and check for expected replies. Once connected, sensor data will appear on the LCD and be uploaded to ThingSpeak. You can view real-time graphs online, anytime, anywhere. And that's it, makers. You have built a Wi-Fi enabled smart environmental monitor using components available right here in Nigeria, real-time data logging, wireless alerts, all done with a few lines of code. Like this tutorial, subscribe for more awesome projects. Visit hubtricity.com.ng to grab your sensors, displays, modules and tools today. This is Hub360 Embedded Spare, helping you bring your ideas to life.